So today we're going to look at what's called the rule of four, which is basically going to be four ways of representing a relation. And so that's going to be the goal for today. You're going to be able to, first of all, determine things called domain and range. We'll see what those are of a relation, and then describe a relation using words, a table of values, an equation, and a graph. So let's get into some definitions just to begin with. And so these are definitions that you can get onto your lesson sheet. So first of all, what is a relation? Well, essentially, sets of ordered pairs, those are what we use to form a relation. So in a sense, an ordered pair is like a coordinate. So 2, 3, x, y. And the reason why we call it an ordered pair specifically is because the order of the two values matters. So as I was saying, 2, 3, you'd have 1 represents your x, 1 represents your y. And when you're graphing that, that's going to make a huge difference because it's going to tell you different meaning in terms of how far horizontally you go, how far vertically you go, depending on that order. All right, so next, let's talk about domain and range. So domain is basically the set of the first numbers in an ordered pair. So if we have a number of ordered pairs, if we were to have like a graph with points on it, we're just looking at the first numbers or the x values. The range is the set of the second numbers or the y values of an ordered pair. So I'll just include that as well. So x values or y values. That's another way to think of it. All right, so for example, let's say you have the points 1, 6, 3, 8, 4, 11. It's just 3 points. That makes our relation. The domain in this case would just be 1, 6, or sorry, not 6. We're looking at the x value, so we have 1, we have a 3, and we have a 4. So 1, 3, 4. And what you'll see, what's already included on your sheet is these curly brackets. So the curly brackets, they tell us where we have a set. So this tells us we have a set. And the set contains the numbers 1, 3, 4. All right, and the range, well, if we're looking at the range, we're looking at the numbers 6, 8, and 11. So let's include that into our range. And generally speaking, we'll write things like our domain and range in ascending order. So it's the set of those 3 numbers. Okay, so let's go ahead and describe relations through a few examples. So let's say we have this relation written down in words. So it says the value of y is 1 more than 3 times the value of x. So let's translate that first of all into an equation. So let's read through it very carefully. So we have the value of y is. So that is kind of telling us equal. So that tells us, first of all, the value of y is, so y equals something. What does it equal? Well, let's take a look. So it says 1 more. So we can think of 1 more as in plus 1. And then it says then 3 times the value of x. So we have 3 times. So like 3 times the value of x. So x. So 3 times x. So what we can do, so we can write down 3 times x. So 3x that would just be. And then we know it's 1 more than that. So plus 1. So there is our equation that we've created based off that description in words. Okay, so next we could go and use the table of values. So what numbers are we going to write down in our table of values? For the numbers, what we're going to do is we're going to make use of our domain. So the domain tells us which x values to use. And so let's write those x values into the table of values. So we have -1, 0, 1, 2, 3, 4. And now we're calculating out what values go into the table of values. So remember, when we were calculating out values going into a table of values, we took our x value. So let's see, we took -1. And to figure out what goes into the column here next to it, well, what we do is we write down the equation. We're doing 3 times that value, so 3 times -1 plus 1. So essentially, we're replacing this x in the equation with -1. And if we calculate that out, 3 times -1 is -3 plus 1, which is equal to -2. And so then on our chart, we write down -2. And so we keep doing this for the various values. So what is 3 times 0 plus 1? Well, that would just be 0 plus 1, which is just 1. So that would be the next number in our table of values. Next, we have y equal to 3 times 1 plus 1, which is just 3 plus 1, which is 4. So that would be the next number in our table of values. So all you really need for your table of values is the numbers. I'm just showing the calculations so you know as you're watching this video how those are coming up. So next is 3 times 2. Again, we're just taking whatever number is in our table and writing it up here instead of x in our equation, plus 1. So 3 times 2 plus 1, 6 plus 1, which is just 7. So that's going to go there. Next, we have 3 times, now it's going to be 3 plus 1, which is going to be 9 plus 1, which is just 10. And the last one, 3 times 4 plus 1, which is 12 plus 1, is 13. Okay, so there's a look at the values in the table of values. The next step for us is to use that table of values to finish off our domain range. So we know what the x values are. Now that we've written down the y values, those y values make up our range. So we have -2, 1, 4, 7, 10, 13. Oh, and just remember, we use curly brackets. So not just curved, but they have the little squiggle kind of in the middle. That indicates we have a set. So it is a very specific type of notation. All right, and the last thing that we can use to describe a relation is just ordered pairs. So the ordered pairs, that's where we combine the x value with the corresponding y value. So something like -1, -2, they're beside each other. That is the ordered pair. 0, 1, that's the next one on the table. 1, 4, 2, 7, 3, 10, and 4, 13. And again, remember when you're writing down ordered pairs, always in brackets, your x value, then your y value. And with those ordered pairs, you could graph those down to create a graph. And so that is why we call this the rule of 4. So there was 4 main ways we were describing our relation. There was the way in words, the actual, like, it's 3 times or 1 more than 3 times the number. We could use an equation, we could use the table of values, or we could use a graph. And we can get the graph by determining the ordered pairs. Okay, so let's look at this one more time. So in this case, we are now given the table of values. So we won't necessarily be given the same starting point, but we want to be able to figure out how can we describe it in these different ways as long as we're given some sort of information. So if we're given this starting point, we can start with writing down our ordered pairs. We have the point 0, 0. Again, we're just matching up the 2 side by side. The 2 side by side give us our points. So 1, 1, 2, 4, 3, 9, and 4, 16. And we can also very quickly do our domain and range. So domain is the x value, so 0, 1, 2, 3, 4. And 0, 1, 4, 9, 16 for our range. And again, those curly brackets. And what I'll do is I'll quickly give you an alternate way of writing the domain. So what you can see is for the domain, we've listed all of the integers, so all the whole numbers between 0 and 4. So you could also write it as an interval, like 0 less than x less than 4. Or as in between x is between 0 and 4 is what that says. So that's an alternate way of doing that. And so we'd say that interval, and we'd also just say x is an integer. And we say z, I know it's a weird letter, but z represents integers. So x is an integer. So that's an alternate, but listing it is fine as well too. All right, so what would the equation be here? What's actually happening with our values of x to give us the y value? Well, if we look at the values, what's actually happening is the numbers that we've listed, 0, 1, 4, 9, 16, those are all perfect squares. So actually all that's done is we've just squared the x value. So in a sense, the equation is y equal to x squared. Since something like 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16. Well, no, first one, 0 squared, well, that's just 0. So in words, we could say the y value is the square of the x value. And so that's what we have there. For your purposes, when we're looking at table values and getting equations, we're going to try to keep them simple. So it's not like you're going to have to be figuring out crazy equations based off a table of values. All right, lastly, now let's take a look at some graphs. We did say that was part of the rule of 4, and so we can do that. So for these examples, let's first of all express the relation as the set of ordered pairs. So you can see on the graph we have some points, so we'll take that as our ordered pairs, and then we'll write the domain and range based off of that. So for the first point, this one here, well, that's 3 to the left and 3 up, so that would be -3, 3. The next point here, that's going to be no horizontal movement, so we're at 0 for an x value, and then up 2. So 0, 2. And the last point, we go 3 to the right and up 1, so 3, 1. So that is our set of ordered pairs. So when we write down our domain, we can write this as -3, 0, 3, since that is our three x values. So -3, 0, 3. Next, let's take a look at our range. So our range is the y values. So we can take a look at the y values. We have a 3, a 2, and a 1. As I said earlier, when we're writing down these domain and ranges, we like to keep things in ascending order. So we'll just write it as 1, 2, 3. So it doesn't have to correspond directly with the domain like how they were as points. That doesn't matter as long as we just have the values of the y coordinate parts and the values of the x coordinate parts. So let's do another one. So in this one, the points are a little more spread out, but we can still write them out as ordered pairs. So we have point A, it's 5 to the left and down 2. I'm going to just go in order of the letters. So B, 2 to the right, down 1. C, 3 to the right, or left, so -3, down 3, so -3. D is 2 to the right, and up 4, 2, 4. And the last one, E, is 2 left and down 5. So -2, I'm just going to write it below -5. So I didn't quite have enough space there. All right, so again, the domain. So the domain, let's identify our x values. We have -5, 2, -3, 2, -2. So first of all, let's write it in ascending order. So starting with our smallest value, -5. The next value is -3, the -2, and we have 2 2's. So for that, you only have to write the value once. So if it repeats, as long as we have it once in our domain, that tells us that x reaches a value of 2. We don't need to write it again. So that's another important point for the domain and range. You don't have to repeat values in those sets of numbers. When we have that set of numbers, we're just saying at some point, somewhere in the relation, that number 2 shows up, whether it's once, whether it's twice, or more than that. For the range, we have -2, -1, -3, 4, and -5. So let's write that down again in ascending order. So starting with the smallest, so -5, -3, -2, -1, 4. And there's our range. All right, let's take a look at just one final example to wrap up this lesson. So for the final thing that we want to look at, let's look at a pre-drawn graph. So in this graph, it's actually the graph of the equation y equals 3x plus 1. But let's look at the points. So you can see there's points. They might not be as clear as they should be. But we have these points. So we could start off our range and our domain using those points. So you can see the x values begin at 0. So that has an x value of 0 here. This one has x value 1, 2, 3, 4. We're looking at x values. So 1, 2, 3, 4. Okay, what about y values? So in terms of y values, let's just take a look at those. So we're at a height of 1, then 4, then 7, then 10, then 13. So I'm going to start writing that out. 1, 4, 7, 10, and 13. So that's what you would have if you were just looking at those particular points that I labeled. But we have a full line drawn on that particular picture. So like you can see the question below, that's not on your sheet. Don't worry about that. But we're just going to use that to think things through. So for example, at 2.5, that's in between 2 and 3. So that'll be somewhere here. Since we've drawn the full line in, that is also actually a point on the graph, or a point in that relation. So this is also a point. And in fact, you could do any sort of point or number. So like if you did 0.5, well, that's on the graph. You go way down here. And the thing is with this graph, the line's cut off, but the line would keep going on and on forever and ever in both the direction to the right and to the left. And so what that means is not only do we have these values in the domain, what we actually have is all x values occur. Because we could stick in the number 10, and theoretically that line just keeps going up and it would reach 10. So to write down if all the x values are occurring, what we would say is we would actually write down our domain as x could be, or it looks like an E. This means an element of. And what we say is the real numbers. So that is the real numbers. And if we remember way back to the start of the year, towards the start, real numbers are basically any number that you can think of. So any fraction, square root, anything like that is a potential real number. And so any number is possible. How about for the y values? Well, the y values are going to be the exact same thing. You can reach any sort of height, whether up or down. Every y value is attained. So we can write that as y, an element of the real numbers as well too, as opposed to just those values we looked at for those particular points. So these two, y an element of the real numbers, x an element of the real numbers, that is the real domain and range of that particular line. All right, so that is everything for this lesson.